You are faced with a constant influx of information and decisions that your brain has to prioritize and decipher. And this is simple things like choosing which groceries to purchase at the supermarket or picking a film to watch on a streaming service. It can often be challenging to make important decisions in everyday life. And thankfully, this information overload is a shared experience, and as such, there are a multitude of algorithms to help reduce it. For example, supermarkets have loyalty cards to recommend products to individual customers, and streaming services often recommend shows or movies to watch based on what you've expressed interest in before. Still, as I'm sure you know, this doesn't always help, and people often find such algorithms invasive or annoying. In 2022, OpenAI released ChatGPT, the first ever large language model available to the general public. LLMs have the power to provide answers to an extremely broad variety of questions, and if trained on a specific dataset, can be accurate and powerful tools. Whilst this may seem like a cure-all solution, large language models are not without their flaws. For example, whilst LLMs may be good at answering general questions, they often lack the knowledge or context to answer questions in specific industries or areas. And this raises the question, can LLMs really address the complexities of personal decision-making in more diverse fields? One such field that we are all familiar with is education. Here, AI is not yet widely used, trained, or even really accepted, as it can often be seen as a tool used for plagiarizing or cheating on assignments. Because of this bad reputation, the massive potential of AI in education is sadly overlooked. For example, if set up correctly, AI could be used to help reduce the amount of information overload students face in a degree program by answering any trivial questions that they may have. If an AI chatbot were to be introduced that could take this module information, streamline it into a simple, questionable interface for students to use, perhaps they would have an easier time accessing information essential to their degree. And this brings me on to the main purpose of this project. To answer the research question, is student learning and engagement positively affected by the implementation and integration of an automated chatbot system? So how did I go about answering this question? Well, I needed to accomplish three things. First, I needed to research how to actually make such a system, identifying and comparing existing technologies to see which ones suit the project best. Then, I needed to actually develop the system, and I had to do it quickly enough that there would be enough time for students to play around with it. And finally, I needed to actually get a class of students to use it and evaluate it throughout the semester. It is also worth noting that I'm not the first person to attempt such a task. In fact, this project takes the ideas presented by Alan et al. In their initial QModuleBot project and expands upon them to develop a completely integrated AI chatbot for students to use. I drew a table of features for my implementation of QModuleBot and populated it with information from other systems for comparison. None of them achieved all the goals that I had set out for my system. I also listed a series of key technologies and compared them based on their strengths and weaknesses. Through this, I ended up choosing my pipeline, RAG, which I will discuss in a moment. The main idea behind this system is usability. I have set out to create a chatbot that can generate information on modules based on just a URL, so that any organizer can implement it into their modules. So what technologies did I use to create such a system? Well, a lot of them. As I was working with AI, I built the backend in the Python framework Django. I used LangChain for building my pipeline, Selenium and Beautiful Soup 4 for scraping QM+, and Heroku for hosting. I also built my front end with Vue and Daisy UI, and hosted my server with Postgres and the PG Vector extension. The core functionality of the system is split into two pipelines, generating a module and speaking with it. Here's the generation pipeline. First, the system scrapes the provided QM+ page, logging in with the provided credentials and downloading only the relevant sections of the page. Next, this information is paired with any additional files uploaded. After that, the information is split into smaller chunks so that only relevant sections of information will be retrieved in future queries. Then, these chunks are converted into embeddings, which are essentially vector representations of the text. And finally, these are all stored in the database to be looked up later. Now, this may seem complicated, but as a user, you simply do this. Click, type, click, click, done. As for retrieval, that is, actually talking with the module, it's a little bit less linear. A user asks a question, and this prompt is compared against all the stored chunks of information. The two most relevant results are then taken as context for the answer. Then, the user's query and these relevant chunks are combined by an LLM to form a response, which is sent to the user and memorized, so that it can be used as context for future questions. The user's message and the system's response are both stored in the database, so that they can be used for analytics and are saved for the user when they next log in. But from the perspective of a student, they simply ask the module bot a question. Better speed up. This process I have just described is known as RAG, Retrieval Augmented Generation. This is a very powerful process as it allows for contextually relevant responses without having to spend time training an AI model from scratch, a procedure that would be impractical to do every time a new module were to be generated in the system. The main downside to RAG models, however, is how difficult they are to test. With most systems, a developer can simply create a set of unit tests to ensure functionality, but this is not so simple with RAG, as it can be hard to measure the accuracy of responses. Thankfully, a tool known as Langsmith helps with this and allows developers to see which embeddings are being used to generate responses and to work out how accurate they are. It was through using this system that I was able to fine-tune my settings for the RAG. Now, what I've done for this project is taken this concept and integrated it into a full system, with a dashboard for analytics, a page for managing module members, a settings page for disabling, editing, or regenerating a module, and a profile page for tracking your interactions with the system. All of this designed with simple interactivity in mind. Once this was created, it was time to get some students to give it a go. This year, I was a demonstrator for the first year module Fundamentals of Web Technology, and a number of students kindly agreed to participate in the study and try out QModuleBot. Of the 50 initial sign-ups, about half completed the final survey, which gave me valuable insights for analysis. I also recorded frequencies of interaction throughout the second semester, and found that students interacted with the system most regularly when they had module deadlines approaching. Students were also tasked with completing 2 surveys, one before and one after interacting with the module bot. In the end, 88% of students found that their queries were resolved faster when using QModuleBot. I think it is likely that those students who didn't find their queries answered faster had questions that the module bot simply did not have the information to answer. One student said that an issue they encountered was that if QModuleBot did not know an answer to a question, it didn't answer it. For future work, it would be good to extend the bot to suggest points of contact in this scenario, or to more clearly state that it simply didn't have the information required to answer the question. 92% of students stated that they would appreciate the use of QModuleBot in their other modules, which, due to the implementation of the bot, would be extremely simple to do, requiring no technical expertise at all. Interestingly, most students claimed to have only occasionally interacted with QModuleBot, but this was not wholly unexpected. In the first survey students conducted, most said they only occasionally found themselves with questions for the module, so they most likely would not have to use the system that regularly. Another factor that should be considered is the fact that QModuleBot is hosted on an entirely different website to QM+, that students may not immediately think of to visit. In fact, one student suggested the improvement of including QModuleBot as a QM+ add-on, which would be an excellent addition for future work. Overall, most students rated QModuleBot as 4 out of 5 or higher, which is a result I'm very happy with. So, in answer to the research question, is student learning and engagement positively affected by the implementation and integration of an automated chatbot system, I would conclude that yes, it is. This project set out to create a fully integrated AI chatbot that was simple to use for both educators and students, and based on my analysis results, I would say that not only did it achieve this goal, but it demonstrated the huge potential for artificial intelligence in the future of education. Whilst there are areas in which this project could be expanded upon, I think it served well in acting as a functional demonstration of the capabilities of AI in this field. I look forward to seeing where such technologies progress in the future, and I thank you for taking the time to watch this video.